Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing how to solve linear absolute value equations, which is a topic that occasionally appears on the Mathematics Knowledge subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB. This video, in case you're wondering, is broken down into two parts. In the first part of the video, I'm going to discuss how to solve these linear absolute value equations. And then in the second part, there's going to be 11 practice problems, which I strongly encourage you to attempt to work out on your own. More specifically, I recommend that after I read a question, you pause the video, attempt to work out the question on your own, and then resume playing the video to check your solution. So all that being said, let's go ahead and get started with today's video. The very first thing I want to say regarding absolute value is this. The absolute value of any integer is always going to be positive. So the absolute value of 5 is an integer, is going to be 5. Likewise, the absolute value of -8 is just 8. Again, -8 is an integer. The absolute value of 0 is 0. Now, what happens when we replace integers such as 5, -8, and 0 with a variable? Well, as you can imagine, things get a little more complicated, and the absolute value of x equaling 4 actually has two solutions now. X can be 4, and if you plug in 4 for x, you can see that makes a true statement. Again, the absolute value of 4 does in fact equal 4, or x can also be -4. And if you plug in -4 for x, you can see the absolute value of -4 does in fact also equal 4. So in light of the fact that when you start working with variables inside absolute values, things get a little more complicated. I just wanted to take a few minutes to discuss some rules regarding absolute values and linear equations that will help guide your work. So let's take a look at them. The very first rule says isolate the absolute value and identify what the isolated absolute value is set equal to. So let's go ahead and attempt to do that for these three examples. So for example A, you can see we have the absolute value of 3x plus 12 plus 7 equals 7. Well, we want to get the absolute value by itself. And in this case, we have a plus 7 hanging out here. So let me go ahead and copy this down as if it was on my own scratch paper. We have 3x plus 12 plus 7 equals 7. Again, to isolate this absolute value, that is 3x plus 12, we're going to subtract 7 from both sides. This will cross out here since 7 minus 7 is 0, leaving us with 3x plus 12 equaling 7 minus 7, which is also 0. So as you can see, we have our absolute value all by itself on one side of the equal sign, and we can see that this absolute value is equal to 0. Again, the second part of this first step is to identify what the isolated absolute value is equal to. In this case, it's equal to 0, and we're going to see how to approach that in just a few minutes. All right, let's work out this next one. We have the absolute value of 3x minus 7 plus 7 equals 2. Again, we want to isolate the absolute value. That is, we want to get it all by itself on one side of the equal sign. So in this case, we're going to have to subtract 7 from both sides. This will cross out, leaving you with the absolute value of 3x minus 7 equals 2 minus 7, which is -5. All right, so we isolated our absolute value, and we can see that it's set equal to -5. All right, let's do it for example C now. We have the absolute value of 3x minus 7 plus 7 equaling 9. Again, we want to get that absolute value by itself and then see what it's set equal to when we do that. So we're going to take 7 from both sides to get 3x minus 7 by itself. 9 minus 7, of course, is 2. So in this case, we have our absolute value by itself. And as it happens, it's set equal to positive 2. All right, so now that we've isolated our absolute values for each of these and saw what they were set equal to, let's take a look at these additional rules. Uh, A here says, if the absolute value is set equal to 0, remove the absolute value symbols and solve the equation to get just one solution. So if we look at A, B, and C here, we can see that A is set equal to 0. So let's go ahead and work on this one. We have 3x plus 12 equal to 0. And according to these instructions, we're going to remove those absolute value symbols and set this equation equal to 0. Now we're just going to solve it. The first thing we're going to do is subtract 12 from both sides. This crosses out here, leaving you with 3x equals negative 12. Divide both sides by 3. This crosses out, leaving you with x equals negative 12. Divided by 3 is negative 4. Okay, so in this case, we have one solution since our absolute value is set equal to 0. More specifically, it's negative 4. All right, B says if the absolute value is set equal to a negative number, there is no solution. So if we look at B right here, you can see that our absolute value is set equal to negative 5 right here. So we have 3x minus 7 equaling negative 5. Again, in light of the fact our absolute value is set equal to a negative, we know for this one there's going to be no solution. All right, and finally, let's look at our third rule. C says, if the absolute value is set equal to a positive number, set the argument equal to the number and set it equal to the opposite number, and then solve each equation separately to get two solutions. Well, if we look up here, we can see that we have 3x minus 7 equaling 2 right here. So let's just go ahead and copy that down right here. We have the absolute value of 3x minus 7 equaling positive 2. And according to this, we break this apart such that we have one equation equal to positive 2 and the other equation equal to negative 2. And now we just solve them accordingly. So let's go ahead and do that. For this one, we're going to add 7 to both sides. This crosses out here, leaving you with 3x equals 2 plus 7, which is 9. Divide both sides by 3. This crosses out, leaving you with x equals 9 over 3, which is just 3. All right, so one of the solutions to this absolute value equation is x equals 3. Let's do the same thing over here now. We're going to add 7 to both sides. This crosses out here, leaving you with 3x equals negative 2 plus 7 is going to be 5. Divide both sides by 3. This crosses out. That leaves you with x equals 5 over 3. All right, so since this absolute value was set to a positive number, we can see that we now have two solutions. All right, so that's all there is to solving linear absolute value equations. Again, if after you isolate the absolute value, it's set equal to 0, there's only going to be one solution. If after isolating the absolute value, it's set equal to a negative number, there's no solution. And if after isolating the absolute value, it's set equal to a positive number, there's going to be two solutions. Pretty easy to remember. So with that in mind, let's go ahead and get started doing some practice problems here. This first one says the absolute value of x equals 8. So again, if you recall, the very first thing you want to do is to attempt to isolate the absolute value. In this case, that's already done for us. So the next thing you want to do is to look at what the absolute value is set equal to. In this case, it's set to a positive value. So in light of that, I know there's going to be two solutions to this one, notably x equals 8 or x equals negative 8. All right, so that's that one. Let's look at number 2. We have the absolute value of x minus 2 equals 6. Again, you want to attempt to isolate the absolute value if it's not done for you already. In this case, it's already done for us. And then you want to check to see what that absolute value is set equal to. In this case, it's set equal to a positive value, so we know there's going to be two solutions. And we're going to drop these absolute value bars so we can write x minus 2 equals 6 or x minus 2 equals negative 6. Now all we have to do is solve for x. In this case, we're just going to add 2 to both sides. This will leave us with x on this side since these cross out. And as we can see, x is equal to 6 plus 2, which is 8. And in this case, we're going to add 2 to both sides. This will cross out here, leaving you with x equal to negative 6 plus 2 is negative 4. Okay, so for number 2, there's two solutions, notably x equals 8 or x equals negative 4. All right. For number 3, you can see we have x plus 1 equaling 0. Since our absolute value is already isolated, we're going to look at what it's set equal to. In this case, it's set equal to 0. And in light of that, we know we're just going to have one solution in this case. So we're going to drop our absolute value bars and set this equal to 0. Now we're just solving for x. So we're just going to subtract 1 from both sides. This says x equals 0 minus 1, which is negative 1. All right, let's move on to number 4. Again, as we can see, we have the absolute value of x minus 4 equaling negative 6. Our absolute value is isolated, so we're looking at the value to which it's set, and we can see that it's set to a negative value. If you remember our rules, this results in a situation where there is no solution. Again, if an isolated absolute value is set equal to a negative value, there's no solution. All right, so number 5 says 3x plus 2 equals 10. Again, our absolute value is isolated for us, and we can see it's set equal to a positive value. So we're going to have two solutions in this case. One's going to be 3x plus 2 equals 10, or 3x plus 2 equals negative 10. All right, let's go ahead and solve for x now. The first thing we're going to do over here is subtract 2 from both sides. This will cross out here, leaving you with 3x equals 10 minus 2, which is 8. Now we're going to divide both sides by 3. This crosses out, leaving you with x equals 8 over 3. Let's do the same thing over here. We're going to subtract 2 from both sides. This will cross out, leaving you with 3x equals negative 10 minus 2, which is negative 12. Let's divide both sides by 3 to get x by itself. And this says x equals negative 12 divided by 3. We have a negative divided by a positive, so we know our result's going to be negative 12 divided by 3, more specifically, is 4. Okay, so for this one, we have two solutions, notably x equals 8 over 3 and x equals negative 4. All right, if we look at number 6, you can see we have 2x plus 5 plus 4 equals 3. Our absolute value in this case is not isolated, so we're going to have to do that. Let me just go ahead and copy that down over here. We have the absolute value of 2x plus 5 plus 4 equals 3. To isolate our absolute value, we're simply going to subtract 4 from both sides. This will cross out here, leaving you with the absolute value of 2x plus 5 equals 3 minus 4, which is negative 1. Now that our absolute value is isolated, we can see that it's set equal to a negative value. And in light of that, we know there's going to be no solution for this one. All right, let's keep going through these practice problems here. We're almost done. All right, number 7 says we have 2 times the absolute value of 4x minus 1 equaling 6. So as we can see, our absolute value is not isolated, so let's work on getting that done first. I'm just going to copy this down over here. We have 2 times the absolute value of 4x minus 1 equaling 6. To get this absolute value by itself, we're going to divide both sides by 2. This will cross out here, leaving you with just the absolute value of 4x minus 1 over here. And 6 divided by 2 is 3. So now that we have our absolute value by itself, we can see that it's set equal to a positive value. And in light of that, we know there's going to be two solutions, notably 4x minus 1 equaling 3, or 4x minus 1 equaling negative 3. All right, so now let's just solve for x in both of these cases. For this one, we're going to add 1 to both sides. This is going to cross out here, leaving you with 4x equaling 3 plus 1, which is just 4. Divide both sides by 4 now. This crosses out, leaving you with x equals 4 over 4, which is just 1. For this one, we're going to add 1 to both sides. This crosses out here, leaving you with 4x equals negative 3 plus 1, which is negative 2. Divide both sides by 4 now. This crosses out, leaving you with x equals negative 2 over 4. We can reduce this fraction by dividing its numerator as well as its denominator by a common factor of 2. So this becomes x equals negative 2 divided by 2 is 1. 4 divided by 2 is 2. So x equals negative 1/2 in this case. All right, so that's that one. And you may have noticed that these questions are getting a little more difficult as we progress through this section. For number 8, you can see that we have 1/4 times the absolute value of 2x minus 6 plus 1 equaling 2. Of course, our absolute value is not isolated, so that's going to be the very first thing I'm going to do in this case. So let's just copy this down. We have 1/4 times 2x minus 6 plus 1 equaling 2. Let's go ahead and subtract 1 from both sides. This will cross out here, leaving you with 1/4 times the absolute value of 2x minus 6 equaling 1. Now to get rid of this 1/4, we're going to multiply it by its reciprocal, which is 4 over 1, or just 4. We're going to do that to both sides. This crosses out here, leaving you with 2x minus 6 equaling 4. And now we have our absolute value isolated, and we can see it set equal to a positive value. And in light of that, we know there's going to be two solutions to this one, notably 2x minus 6 equaling 4, or 2x minus 6 equaling negative 4. Let's go ahead and solve each of these. For this one, we're going to start by adding 6 to both sides. This crosses out, leaving you with 2x equaling 10. And my pen's starting to act up a little bit. Divide both sides by 2. This crosses out, leaving you with x equals 10 divided by 2, which is 5. All right, for this one, let's add 6 to both sides. This crosses out here, leaving you with 2x equals negative 4 plus 6, which is positive 2. Divide both sides by 2. This crosses out, leaving you with x equals 2 over 2, or just 1. So the two solutions to number 8 are 5 and 1. All right, let's work on number 9 now. We can see that it says negative 3 times the absolute value of x minus 1 minus 6 equals 3. So to start, I'm going to go ahead and copy this one down right here. We have negative 3 times the absolute value of x minus 1 minus 6 equals 3. So again, our goal is to get the absolute value by itself. So let's add 6 to both sides here. This crosses out here, leaving you with negative 3 times x minus 1 equaling 9. Now to get rid of this negative 3, we're going to divide both sides by negative 3. This will cross out here, leaving you with x minus 1 absolute value equals 9 divided by negative 3. Well, positive divided by a negative is going to be a negative. 9 divided by 3 is 3. So in this case, we have an absolute value set equal to a negative value. So that's going to be no solution. All right, let's move on to number 10 now. Number 10 says the absolute value of x minus 7 plus 2 equals 2. So again, we have x minus 7 plus 2 equals 2. The very first thing we want to do is get this absolute value by itself or isolate it. So we're going to subtract 2 from both sides to start. This will cross out, leaving you with absolute value of x minus 7 equals 2 minus 2, which is 0. In light of the fact that our absolute value equals 0, we know there's just going to be one solution, notably x minus 7 equals 0. And now we're just going to add 7 to both sides to solve for x. This crosses out, leaving you with x equals 0 plus 7, which is just 7. All right, so that's that one. All right, for number 11, we have the absolute value of 3x plus 2 equal to the absolute value of x minus 6. This is a pretty challenging problem, and so if you want me to walk you through it, I will, but otherwise go ahead and try it on your own. The key to this problem is to do this. We're going to do, first we're going to drop the absolute value bar, so we're going to have 3x plus 2 equaling x minus 6. That's one possible solution. And our other possible solution will be this, 3x plus 2 equaling, we're going to take a negative and distribute it to everything else in the second absolute value. So that's going to be negative x minus 6. All right, let's work these out accordingly. We have to solve for x over here. So the first thing I'm going to do is subtract x from both sides. This will cross out here, leaving us with negative 6 over here. And negative 3x minus x is 2x plus 2 equaling negative 6. Now let's subtract 2 from both sides. This will cross out here, leaving you at 2x equals negative 6 minus negative 2 is negative 8. Divide both sides by 2 now. This will cross out, leaving you with x equals negative 8 over 2, which is negative 4. All right, let's work on solving this one now. The first thing you want to do is take this negative and distribute it here and here. So we have 3x plus 2 equals negative times positive x is negative x. Negative 1 times negative 6 is positive 6. Let's go ahead and keep working this one out now. First thing I'm going to do is add x to both sides to get rid of it from here. This becomes 4x plus 2 equals 6. Now we're going to subtract 2 from both sides. This will cross out here, leaving you with 4x equaling 6 minus 2, which is 4. Divide both sides by 4. This crosses out here, leaving you with x equals 1. So the answer to this one is x equals negative 4, or x equals 1. That is to say it has two solutions. Sometimes as you work out these questions in which you have an absolute value equal to another absolute value, you'll reach a point where you'll have like something like this, 0 equals 5. In that case, it wouldn't be the solution. So that's that one. All right, so that is it for this video. I hope you found it helpful. As always, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose.
こんにちは。